So hello everyone, this is Akash. Welcome to you all into the 6th episode of my LinkedIn initiative, that is the VLSIpedia. So today we're going to discuss about this nanometer process technology. So before starting this video, I would like to share a small story about myself. When I was just beginner into this particular VLSI domain, I was reading these particular articles from these various companies like Intel, NXP Semiconductors, ARM, etc. was learning these various kinds of the HDS. And while reading this article, I always strike with this word like Snapdragon's this processor is built on the 7 nanometer technology or the 5 nanometer technology. So I often wondered what they actually mean. So I've done the research and found that particular answer, and the same thing we're going to discuss today. So let's start today's video. So first of all, we all often seen this particular image on this Google, like Apple boosts this iPhone 13 model with this 815 Bionic chip, which consists of this various kind of the 9 nanometer technology. Also Samsung's productions for this 3 nanometer process. Then Intel said this earlier leg of using this 10 nanometer enhanced super fin process. Also the global Unichip supports Taiwan Semiconductor manufacturing companies 3 nanometer technology, etc, etc, and etc. So there's a common word, that is this nanometer technology. Like in 5 here you can see here it's the 5 nanometer, it's the 3 nanometer, it's 10 nanometer, 3 nanometer again. So what they actually mean? So that's the thing. What is this particular nanometer process technology? So first thing, it is not the rocket science. It's not that much difficult. It's basically just the length of this transistor gate. That's it. So if this is a particular enhancement type MOSFETs. We all know this particular enhancement type MOSFETs, and there is a source drain having this heavily doped and channels. Also there's a P substrate. There's a gate which is covered with this polysilicon layer. Also I have discussed in the previous episode like why enhancement type MOSFETs are preferred into this particular IC fabrication. You can go and watch that particular video. So coming to this main point, so nanometer process technology. So here I'm showing you the gate length. Suppose the gate length of the transistor that we have built, it is 10 nanometer. Then with this particular transistor, if we develop a processor, then we can call it as a 10 nanometer processor technology. If this gate length is, suppose say 5 nanometer, and I have built this particular transistor, I have designed it, and on the basis of this particular transistor I have designed my processor or other kind of devices, then we can call it as a 5 nanometer technology. So it's nothing that much difficult. It's basically the gate length. If gate length is a 10 nanometer, it's 10 nanometer process technology. It's 3 nanometer, then 3 nanometer process technology, and that's it. So what is the use of this particular nanometer process technology? The smaller the gate size, the transistor becomes smaller and smaller, and as this transistor becomes smaller, the package density, the amount of the transistor, number of the transistor embed on this particular single chip goes on increasing, and it gives the more packaging density, more processing power, and due to which the processor becomes much faster and powerful. So here I am showing this particular evolution of this process technology. So as we know, this our electronics industry started around in the 1950s. So at that particular time, in the year 1957, the first transistor is introduced which having the 120 micrometers. So I am showing here the nanometer scale. It's a 1,20,000 nanometers, which is equals to 120 micrometer. So the transistor which was built in the year 1957 was of this particular 120 micrometer. So the gate length of that particular transistor is the 120 micrometer, and the devices were built on this particular technology. But as this particular time goes on increasing, this technology becomes advanced and advanced, and this particular gate length goes on decreasing. First it was a 120 micrometers, then it becomes 30 micrometer, 6 micrometer, 3 micrometer, 1 micrometer, and goes on decreasing. And right now in our all kinds of the devices that we use today, that's all are based on either 10 nanometer, 7 nanometer, or this 5 nanometer technology. So basically 10 and 7 nanometers technologies are more popular right now today, and if you are using this advanced kind of devices, then it uses this particular 5 nanometer technology. So in future, like I'm going to discuss that part into the later slides, but in future, in year around 2022, there will be a 3 nanometer technology will be introduced, and also in around year 2024, the 2 nanometer technology is upcoming, and this 2 nanometer technology will become the revolution in this particular electronics industry and as well as VLSI industry, due to which this processor becomes much faster. We will get the highly qualified and this advanced processor which can combine both CS and electronics domain with this advanced technologies like AI, ML, IoTs, etc. So same thing I have discussed with this particular graph. So here on the horizontal x-axis, I am showing the timeline as from year 1987 to right now. It's of the 2019, and in the horizontal, in vertical axis, I am showing this gate length and the process technology. As the time goes on increasing, this particular gate length goes on to decreasing. First, it was a 3 micrometer, then 1.5, 1.2, and it goes on decreasing and decreasing. And in particular year 2019, the 5 nanometer technology, which is most recent and it's using into this particular various kind of the advanced processor right now. This is particularly the 5 nanometer technology. So the next and most important part is the Moore's law. So we all aware about this Gordon Moore, who is the co-founder of this Intel Corporation. So they have stated a particular law in year 1968, like the number of transistors on the microchip doubles every 2 years. So he said that particular consider a microchip, like we keep this particular length and the dimension of this microchip, it's same. And over the years, the technology will be advanced in such a way that the microchip size will and dimension will remain constant, but number of transistors we can build on it goes on doubles every 2 years. Some people call it as a doubles every 18 months also. So here again I am on this x-axis, I am showing here timeline from year 1970 as the law is stated in the year 1968, from this 1970 to this 2020 recent factor. And on this vertical axis I am showing this transistor count. This is the number of transistors can be built on a single microchip. It's the scaling from this 1000 to almost 5 billion. So as you can see here, this particular transistor number of transistors which are fabricated over a single microchip goes on increasing and increasing. Also I am showing here this the processors and the technology which are based on it, and the recent 2020 it's a processor which almost consists of the 5 billion transistor on a single microchip. So nextly, the future, like as I told at the start, the 3 nanometer, 2 nanometer and the 1 nanometer process technology. So on the May 6th of the 2021, like 4 months back, the IBM unveils that the world's first 2 nanometer chip technologies. Also they have stated that particular this 2 nanometer technology will be come into market around the year 2022 or at this start of this 2023. So also in the month of July 21, like 2 months back, Intel also revealed their roadmap for this 2 nanometer technology. And for sure this VLSI industry is at the boom level, but there's a second fact also, like we consider this 2 nanometer, it's approximately equals to the atomic length of these 4 atoms. Like if we combine these 4 atoms together, its length will be the 2 nanometer. And we all know that the atoms are unbreakable. So the future is very interesting, and this industry gonna at the boom, because we have to see this particular is the nanometer technology goes on to decreasing and decreasing, whether the gate length goes if in the 0.1 nanometer, 0.01 nanometer on in the pico scale. So this factor will be plays very important role. This field has a lot of interest in the research into the coming future, and for sure, as I told, this industry gonna be at the boom level into the coming 5 to 10 years. So that's it for today. I hope you understand what I wanted to convey to you. So if you find something interesting here, don't forget to hit the like button. If you have any queries, let me know into the comment section. So that's it for today. I'll see you in the next Sunday.